Section 9.1, excuse me, deals with a power series. So first of all, what is a series? An infinite series is an expression of the form a sub 1 plus a sub 2 plus a sub 3, etc. Or written in some notation, the sum, that's what sigma means, as k goes from 1 to infinity of a sub k. So we're adding up all of our a values, starting with a sub 1, continuing on through infinity. The numbers a sub 1, a sub 2, etc. are the terms of the series, and a sub n is the nth term. Now this should look very familiar. We just did this when we talked about sequences. The terms of the sequence were also a sub 1, a sub 2, a sub 3. You notice that the difference is that we then take these terms and we add them up. So a series is the sum of a sequence. Okay, the series is the sum of the sequence. A series, just like sequences, can diverge or converge. So, a divergent series. Does the series 2, negative 2, 2, negative 2, 2, negative 2, on and on forever, converge? If this infinite series has a sum, it has to be a limit of the partial sums. So I first add 2 and negative 2. And actually there should be a 0 here first. Well, they've started with the first term. So 2 is the first partial sum. Adding these together, I get 0. That's my next partial sum. Adding the next 3 together, I get 2 again. Adding the first 4, I'm back to 0. So my sum of the listing of my partial sums is 20202. This has no limit. Therefore, the sum of the series diverges. So when we take the first term, we add the second to it, then we add the third, then we add the fourth. If this sum does not converge, then the series also diverges. A convergent series. The series 7/10 plus 7/100 plus 7/1000, on and on and on. So again, the first term is 0.7. If I add the first two terms together, I get 0.77. If I add the first three terms, I get 0.777. So as I continue to add partial sums, I will eventually, as I go to infinity, have a sum that does converge upon 7/9. 0.7 repeating is equal to 7/9. So this series converges to the sum of 7/9. Again, we're not talking about the terms. If this was a sequence, this sequence would converge to 0 because the nth or the biggest term approaches 0. All right. An infinite series. If the infinite series, the sum as k goes from 1 to infinity of all of our terms, a sub k, if the infinite series converges, then the limit as k goes to infinity of a sub k equals 0. That's what we just said back here. The final term, a sub k, as k goes to infinity, is going to be 0. Since I am adding smaller and smaller and smaller and smaller numbers, the series, or the sum of all these terms, will converge. So our definition again, if the infinite series converges, then the limit as k approaches infinity of a sub k, the furthest out term, must equal 0. This means that if the limit of the a sub k term as k approaches infinity does not equal 0, the series must diverge. Okay, so that's pretty important. A geometric series. A geometric series which is the sum, as n goes from 1 to infinity, of a times r to the n minus 1, converges to the sum a over 1 minus r if the absolute value of r is less than 1, and it diverges if the absolute value of r is greater than 1. So my common ratio, if I am multiplying by a number smaller than 1, my terms are getting smaller and smaller and approaching 0. If my common ratio is greater than 1, then as I multiply by that number, my terms are getting bigger and bigger, and it will diverge. This formula gives me the exact value of the sum of an infinite number of terms in a geometric series. So tell whether each series converges or diverges. So since r is less than 1, it is 1/2, my first term is 5. So using my formula, which again is a over 1 minus r, using a sub 1 here, 1 minus r at the bottom, we can see that this series converges to 10. Now we can try this. My first term is 5. My second term is 5/2, 5/4, 5/8, 5/16, 5/32. If you take these and put these in your calculator and start to add them up, you will see that the total sum gets closer and closer to 10. And it does in fact converge to a sum of 10. Here's another one. Tell whether each series converges or diverges. If it converges, gives its sum. So since r is less than 1, and again, my first term would be 1 here, understood 1 in front of that. The series converges to 1 over 1 minus 3/5 or 5/2. So again, geometric series is pretty easy to find the value of the convergence of the sums as long as r is less than 1. That's all we're going to do for now.